I will be explaining today how we manage to train our data and how everything that we have done to this point, how it actually works. So I will be starting with how we get the data. So we are going to be using Wireshark. The Wireshark we are going to be using is this, and the data I will be getting, they will be coming from my Wi-Fi, my Wi-Fi. And the Wi-Fi is connected to my home network, which is this. So when I go into the Wi-Fi, I can see that I'm receiving bunch of packets. Sorry. So I'm receiving bunch of packets from my home network. With this data, I will quickly use it to train my model and test the anomaly detection process, the IDS. So I will stop the packet capturing now so that I can export them as a PDF. Then analyze packet on format PDF. So I will be saving them in my downloads for now. Then I will say ESG live demo. Then I will register them in CSV. So we have gotten our data now. When I come back to my download files, I will see that the data is here. It's in CSV format. So what I will do is I would like to move this data to where my actual folder is for the data. This is it actually. So it's in my GS M2 Lefic. So I move it here. Going back to my my code here, the data is actually here. It is in this place. So first of all, what will happen is with this data, let me open the data. This is this one. This is basically all the data I captured from my home network. With this data, we can see that we have different features in the data. We have the time, the source, the destination, protocol, the length, the information. We have a lot of things in data. Even there is an IP address in the data, if you see here. So what I will be doing is I will be training this data with my model. The model I will be using is isolation tree. So to train this data, I will first of all go to my Wireshark data. Here, what I will be doing is before I train the data, I have to make sure that I clean up the data. Take like I pre-process the data. Pre-processing data means to take out what is not necessary and save the only data that I actually need. And sometimes data can be noisy, and data could actually there could actually be some parameters that are not needed, because this data is a lot of data. I can't be looking at them one after the other. So with my code here, I will be extracting the IP address from it. The IP address, this is the place I will be getting it. But not the IP address, sorry. The source and the destination port, I will be extracting it from the data. Then, when I extract it, I will be extracting also the time frame, the time the data, the packet was actually received, the source IP, the destination IP, the protocol, and the length. So when I get all these features from the data, I will now have to encode them. Label encoding is basically a way of saying, okay, take the string and convert it to a numerical value, because the algorithms or machine models work better and faster with numerical values. So we are just going to extract these values, then we put them in a label coder. Then the next thing I will do is to standardize the data. Standardizing data, standard scalar actually means a way of making the data like none of the data will be performing more than like all the data will be in a similar scale. Like we are ensuring that all features of this data they are on similar scale so that the model can perform very well. After that, I will save the pre-processed data as my CSV file. Here right now, it doesn't exist, but after I run this code, it will save this CSV file, extracting the ones I need from the data. Then I will be also saving the label encoder and the scalar encoder. So let's run this code. Actually, since I will be loading my Wireshark data. I name it ESG Live Demo, but in my code, it is actually named Wireshark data. So I will be renaming this data. So I have renamed it. Let me see. The data has to be in my code. Yeah, because here I'm using OS. I'm importing OS. Then I'm saying that os.join current directory, meaning it has to be in the same folder. So when I run this code, let me play it. I run this Wireshark data. It is supposed to train my data. So it actually generates three different files: label encoder, scalar, and pre-processed data. They are basically down here. We have the label encoder here, scalar, and the pre-processed data here. Basically, these are artifacts. As I said before, the scalar is a way of standardizing all our features and making sure they are all in a similar scale. The label encoder is to take out all our label encoder here is to take out all the features we need and make sure they are all transformed to a numerical value so that the model can use it. In similar sense, I have treated all my data now. Let me open one of the pre-processed Wireshark data. You can see we have two different data here. Let me open this the first data here. We can see this data here. This is the pre-processed data in this in my left hand side. The Wireshark data is in my right hand side. You can see that this is a raw data. The raw data from the raw data is this, my right hand side. This is the pre-processed data. You will see that this data is more organized and it's more clean because we have taken out what we are going to use to train our model. And in this data is basically raw data from the Wireshark. So that being said, we need to now train the model with few features. The features we are going to be using is the data, the time, the source IP, protocol length, the source and destination IP port. So let's train our data now. Now to train our data, we are actually here now. I'm loading the data. I installed some of Python's libraries like Panda. I'm saying that AS is like an alias, the Nubi NP as the alias. So I'm using sklearn to import my isolation what is it called? Isolation forest. So the isolation forest is a machine learning. It's a model actually, but when we say model, we are basically talking about an algorithm. So this algorithm here, this one here, is from sklearn.